Hey boys and girls, this is Mr. Katz. This is a little video to kind of help you kind of test yourself on whether you understand the chapters 3.5 and 3.6. So basically what your job is to pause the video. I'm just going to go quickly through each problem, but to really benefit from this video, pause the video, do the problem, and then unpause it, and then you can check to see if you're right or wrong. So here's the first problem. How many sides does regular polygon interior angle with a measure of 168 have? So we're going to use our formula. I'm going to use the one that's already simplified. That's how we're going to find, that's a formula for one interior angle, but I know it equals 168. So I'm going to subtract 180 on both sides, which would leave us with 168 minus 180 is going to be, 12. It's going to be negative 12 because you have a negative 180 on both sides. And then we're going to get the n from the denominator, we're going to multiply the whole equation by n, which would get rid of it here and move it to this side. And last, we are going to divide 360 by 12. Well, it's negative 360 by negative 12, so you're going to end up with a positive 30. So that means it's a 30-sided figure. Next problem, pause it, and once you're done, hopefully now you are done. How many sides is a regular polygon with an exterior angle? Well, that's how I find exterior angles. If I knew the number of sides, but I don't know the number of sides, but I knew it equals 20, multiply both sides by n, and then divide both sides by 20, and 360 divided by 20 is, 360 divided by 20. I'm sorry, I did that incorrectly. 360 divided by n equals 20n. So dividing both sides by 20 is 18. Sorry about that. And that means there are 18 sides in that figure. This one we did in class, but just as a reminder, because it gives you each angle algebraically, and then it actually tells you what angle A and C actually equal, we are going to, we can actually make two separate equations. 7x plus 6y, which is equal to, that's what it tells us A is algebraically, it's equal to 73. And since we have an x and a y in our equation, at this point we can either add up all the algebraic angles and set them equal to 540 because it's a pentagon, or we can know that they give us angle C as 13x plus 3y, and they tell us it equals 103. Well, since you have a system of equations, so we're going to multiply this entire equation by negative 2, and that will leave us with, if I multiply every single term here by negative 2, I do that because then if I move the other equation over, I have opposites. I have 6x and I have negative 6x. So if I add both equations, we're going to eliminate the x's, and we're left with negative 19x, which equals, so you have negative 206 plus a 73. Which is a negative 133, and then when you divide that answer by 19, you get 7. So x equals 7, and then we're going to plug it back into one of the equations. We'll plug it into this equation right here, so you get 49 plus 6y, because 7 times 7 equals 73. We're going to do 73 minus 49, subtract 49 on both sides, you get 6y, which equals 24. And then so that y would equal 4. Next problem, go ahead and pause it. Ratio of an exterior angle measure to an interior angle measure is 2 to 3. Well, I don't know what the exterior angle is, but we have a formula to find it. And I don't know what the interior angle measure is, but we have a formula to find that too. And I can't set them equal because it doesn't say they're equal, but it does say that the ratio is 2 to 3. Well, that would mean that this, if I multiply this one by 2, this one is actually, I would be multiplying this one by 3, but to set them equal using this ratio, I'm actually going to have to give the smaller one multiply it by 3. And I'll have to take the bigger one and multiply it by 2. Right? And when I do that, I end up getting 3 times 360. The reason, by the way, we're doing that is because if we have a ratio of 2 to 3, and I were to use a fraction to set a ratio, and we're going to make a proportion, when you go to cross multiply to set them equal, the two, the exterior angle would be multiplied by 3, and the interior angle would be multiplied by 2. Okay, get rid of that. Now to solve it, I'm going to multiply 3, well it's technically 3 over 1, so 3 times 360 is 1080 over n still. And the other one I'm going to multiply, I'm going to have to distribute this to. So you end up with 360 minus, and then you get 720 over n. Now here we want to remember we've got to move our denominator of n to the top so we can solve for it. So I'm going to multiply everything in this equation by n, which would cancel it out here. But I got to multiply this also by n, so it's going to put it there. And I got to multiply this by n, which will cancel that out. So now I have an equation, 1080 equals 360n minus 720. I'm going to add 720 to both sides. So I'm going to get 1800, which equals 360n. So I divide both sides by 360, and I get an answer of 5. So the number of sides is 5. It is a pentagon. Next question, go ahead and pause it. Measure of one interior angle is half the measure of an exterior angle. Well, we could do this two ways. We could set a proportion up. 1/2 equals the interior over the exterior. But after, I'd like to set an equation right from the beginning. If I put the interior angle on one side, 180 minus 360 over n, and I put the exterior angle on the other side, which would be, the formula would be 360 over n. Since I know the interior angle is half, if I multiply the interior angle by 2, I'll be able to equal the exterior angle. I don't really have to put a 1 over there. So if I distribute that 2, I'm going to end up with 360 minus 720 over n, just distributing the 2 to both parts, equals 360 over n. So I'm going to have to do what I did before. I'm going to have to move the n to the top by multiplying every single term in here by n. Leaves us with 360n minus 720 equals 360. So now I'm just going to solve this equation. Add 720 to both sides. So I have 360 plus 720, which will get us 360n equals 1080. And then I'm going to divide by 360. And I will get 3. So this actually number of sides, this works. This is true of a triangle, that the measure of one interior angle is half the measure of the exterior angle. And if you remember from our chart, the interior angle ends up being 60 and the exterior angle is 120. You can see that it's half of it. In this problem, go ahead and pause it. You notice that you're given every exterior angle, because even though this is 90, we know that this is going to be 90 as far as a linear pair. So I'm going to add up all my exterior angles, except obviously for the x. So 48 plus 79 plus 65 plus 90, and you get 282, plus that x, 282, plus x. I know that all the exterior angles have to add to 360. So I can just set this equation, since I know this will always equal 360. I'm going to subtract 282 from both sides, and 360 minus 282 is 78. So x has to be 78, and the angle would be 78 degrees, but we're talking about x, so we don't need the degree sign. All right, last one, actually two more. Go ahead and pause it. Angles of a hexagon below, find x. So a couple things. We need to know what the interior angle of a hexagon would equal, so I'm going to use my formula. Instead of n, I know it's 6 minus 2 times 180. So 4 times 180 is 720. So I know that all of these angles have to add to 720. So I'm going to go ahead and combine them. X squared and 3x squared would be 4x squared. 20x and 20x and 5x is going to be plus 45x. one, and then plus the random 103 has to equal that 720. So I'm just going to go ahead and notice I have a quadratic equation, so I have to move the 720 over. So 103, I'm going to subtract 720 on both sides. So you end up with negative 617, which equals 0. 4x squared plus 45x minus 617 equals 0. Now, you can try to factor this in order to solve it, but because of the just wide array of numbers, you could try to maybe, 45 is not divisible by 4 evenly, so you can't really reduce these problems, nor are they even numbers, so you can't reduce by dividing by 2. So I'm just going to do the quadratic formula. Negative b plus or minus the square root of b squared, so 45 squared, minus 4 times a, which is 4, times c, which is negative 617. And I could already see that's going to work out because a negative times a negative is going to equal a positive. Divided by 2a, so I'm just going to go ahead and just multiply 2 times 4 and make that 8. So a little bit of work that we have to do. So 45 times 45 squared is 2,025. So I'm going to go ahead and do the inside of the square root over here. And I know it's going to end up being plus because negative 4 times 4 is negative 16. But then when I multiply negative 16 times 617, you end up getting 9,872. So when I add that to 2,025, you get 11,000. So I'm going to go ahead up here, 11,897, which is not evenly square rooted. Can't take the square root of it. 11,897. Just going to double check. Nope, it does not go in evenly. So we're going to go ahead and leave it as negative 45 plus or minus the square root of this divided by 8. And I know that I'm not going to use the minus sign because one of my angles is 20x, so I can't get a negative angle. So I'm going to use the negative 45 plus the square root of 11,897. And that's going to get me a positive, it's about a positive 64 divided by 8. And you end up with about, x is about, it actually works out to be 8.00917. So I'm going to say x is about 8. Now, if you were to go to find the individual angles, you couldn't use the rounded answer. You'd have to keep it in your calculator and make sure that you multiply 5 times the real answer. Okay, go ahead and pause it. All right, so here's a little proof. I want you to work on this proof. Some of these on this side you have to finish, and then the reasons you also have to finish. Go ahead and know that in this case L is parallel to M, and over here it says that O is parallel to P. And that was left off the problem. So the measure of angle 2 plus measure of angle 5 equals 180. That was a given. That would mean that L is parallel to M. So L and M are over here. Now I proved that this angle and this angle were supplementary. Well, you can see that 2 and 5 are same side interior angles using L and M as your parallel lines. So that would be the converse of the same side interior angle theorem. Okay. Then we know that angle 3 and 4 are congruent, and angle 3 is over here, angle 4 is over there, but that was a given. And then once I've proven that O and 3 and 4 were congruent, now all of a sudden it says that O and P. Now let's see where O and P are. Here's O, here's P. So 3 and 4 are actually formed from those two lines, and 3 and 4 are alternate exterior angles. So after proving that they're equal, now I know the lines are parallel because the converse of the alternate exterior angle theorem. Then 1 is congruent to 6, so let's see where 1 and 6 are. Now 1 and 6, we've already proven these to be parallel lines, and 1 and 6 are corresponding angles, so they are congruent because that is the corresponding angles postulate. We've already proven parallel lines. Okay. Then 7 and 6 are congruent. So let's see, 7 and 6, use these as your lines. Well, we've already proven L and M are parallel. 6 and 7 are also corresponding angles. So again, that's the corresponding angles postulate. Sorry for the handwriting. And last, 1 and 7 are congruent, which 1 and 7 are not formed by the same lines. So it has to have something to do with here. Well, if you look at this line, 1 and 6 are congruent, 7 and 6 are congruent. You're putting 1 and 7 together, and that's either the transitive property or substitution. The way it's written, I would actually probably say it's more substitution, but either one is fine in this case. And I believe that's the last problem. All right, hope that helps.